Okay, now, so now we have computed a representation of all Boolean expressions with three propositional variables, and I can show you that all the structures if you want. So now we can use this to simplify expressions just by folding them on the structures. Then we find the smallest, the equivalence class to which the expression belongs, and we pick the simplest expression. So I'll take an expression to simplify. Okay, for instance, I take this one. So you can see that it simplifies to 1 because this large expression simplifies to 1, and it is a well-known expression on disjunctive form. But I can also simplify a much more complicated one. Okay, this one, for instance. And you see it's very quick. And this large expression simplifies to a plus not b plus c. And you can see that the simplification time is in fact proportional to the size of the expression. Okay, that's all for the bottom-up algorithm. Now you see that we need a lot of memory to represent all those expressions. So the same method is not applicable for more than 3 variables. So we have designed another algorithm that we call the goal-oriented algorithm, which is able to simplify expression with many more variables, propositional variables. But in fact, this algorithm does not compute all the expression, but it concentrates on expressions that are equal to sub-expressions to the expressions to be simplified. And also, as soon as we find a more simple expression, simpler expression, we forget more or less less interesting set of structures not containing a minimal expression at that step. So it reduces the number of computations to be done. Okay. So I will show you how it works in practice. For instance, I can take the same expression and simplify it. So you see that this time we have a lot of simplified expressions, and in the end we get more or less the same expression. Okay, so but it takes, of course, more time because this algorithm is, in fact, makes more useless computation. Now I can simplify a more complicated an expression with more different variables. Here, an expression with involving not this one. This one, okay, this one involves 5 different variables. And also the simplification is quite fast. We get this simple expression, which can be simplified a little bit more, okay? And we cannot do better than that. But in fact, we have no precise criterion to be sure that it's the more simplified one. But in fact, at this step, we have just two equivalent simplest expression. Now, last example is a much more is an expression containing 15 different variables. This is more difficult. So it takes more time. But in the end, suddenly it terminates and we get 0 as the final result.